So today we will be talking about oxidation reaction and reduction reaction and how to balance these reactions. And very briefly, I want to tell oxidation is basically loss of electrons, which is increase in oxidation number, and reduction is gain of electrons, means decrease in oxidation number. If you want to develop a shortcut to remember this, it is oil and rig. Oil means oxidation is loss, and rig means reduction is gain. So what is an oxidation number? An oxidation number or oxidation state is a number assigned to an atom in a molecule or ion that represents the hypothetical charge the atom would have if all bonds were purely ionic. So it's not a real charge. It's the oxidation numbers are a bookkeeping tool. They help track electron transfer in reactions. So they are not the same as the actual ionic charges. It can be positive, negative, or zero. Positive means electron deficient atom, negative means electron rich atom, and zero means elements in its pure or standard form. So changes in redox reaction. So when oxidation number increases, atom oxidize, and when it is decreases, atom is reduced. Examples: H2 oxidation number is basically zero because it's in a pure state, and Na positive means oxidation number is +1, Cl negative means oxidation number -1, and oxygen is in H2O is -2. And later we're going to develop the formula how to find out this oxidation number. So rules for assigning oxidation number: pure element, any element in its pure form has oxidation number 0. So sodium, oxygen, iron, chlorine, they all have oxidation number 0 because they are in its pure form. Monoatomic ions have oxidation number equal to the ionic charge. So sodium plus has +1, calcium 2 plus has +2, chlorine negative has -1. Third, oxygen. Oxygen oxidation state is generally -2 in most compound, but in peroxide, oxidation state of oxygen is -1, and in OF2, oxidation state of oxygen is +2 because fluorine is very electronegative element. So example H2O, oxidation state of oxygen is -2, but in peroxide H2O2, oxidation state of oxygen is -1. Now coming to hydrogen. Hydrogen has a +1 oxidation state with non-metals and -1 with metals, metal hydrides. So example HCl has oxidation state of +1, but sodium hydride, hydrogen has oxidation state of -1. Fifth rule is sum in neutral molecule. So sum of all oxidation number in a neutral molecule must be equal to 0. So example H2O, you multiply 2 times +1 for the hydrogen and -2 multiplied by 1 for the oxygen, and overall charge is 0. The last rule is sum in polyatomic ion. So sum of all oxidation numbers is equal to overall charge of the ion. So here you see example of a sulfate anion. So sulfate, sulfur you don't know, but for oxygen you can take -2. So S plus 4 times -2 equal to -2, which is equal to the overall charge on the anion. And then if you solve this equation, you find sulfur is equal to +6. So here are some work examples to calculate oxidation number. So let's go one by one. H2SO4, let's do step by step. First step, hydrogen is +1 according to rule 4 as it is bonded to non-metal. Oxygen has oxidation state of -2 from rule 3. So let sulfur be X. Now sum is equal to 0 because there is no charge on this. So 2 times 1 for hydrogen plus X for sulfur, and 4 times -2 for oxygen because there are 4 atoms for oxygen, and that is equal to 0. So if you solve this, you can get X is equal to +6. Now for KMNO4, potassium is +1 according to rule 2 and it is from group 1. Oxygen is equal to -2 from rule 3. So let manganese be X, and fourth step, all the charge equal to 0 because it's a neutral compound. So if you solve here X, you will find X is equal to +7. Now Cr2O7 di-negative. Here oxygen is equal to -2 from rule 3. Let chromium be X, and the sum is equal to -2 here because the overall charge is -2 here. So now if you write the equation, 2 times X for chromium, 7 times -2 for oxygen equal to -2. And then you solve for X, you get X is equal to +6. So chromium oxidation state is +6. Oxidation versus reduction side by side. So oxidation means losses electrons. Reduction means it gains electron. In oxidation, because electrons are lost, oxidation number increases. And in reduction, they gains electrons, so oxidation number decreases. Oxidation, these species are called the reducing agent. So the species which oxidize themselves but reduces other, they are called reducing agent. And similarly for reduction, these the species is called the oxidizing agent because they self reduces and oxidize others. Example for oxidation is iron going to iron dipositive plus 2 electron. Iron here loses 2 electrons. And for reduction, copper 2 plus taking 2 electron forming copper. So here copper is gaining 2 electrons. So remember, oil and rig, oxidation is loss, reduction is gain of electrons. Oxidizing and reducing agent. So now we learn a little bit detail about reducing agent and oxidizing agent. So reducing agent, the species that get oxidized itself. So it gives away electron to the other reactant. So the key traits are its oxidation number increases, but it causes the other substance to be reduced because it transfers the electrons to the other species and help them to reduce. Common examples are magnesium, zinc, iron, H2, and carbon monoxide. Now, oxidizing agent, the species that gets reduced, it accepts electron from the other reactant. So key traits are its oxidation number decreases, it causes the other substance to be oxidized, and here common examples are O2, chlorine, iron, fluorine 2, KMNO4, and proton ion. Now here the example is magnesium plus copper sulfate forming magnesium sulfate plus copper. So here if you see magnesium from 0 in the reactant side is going to plus 2 in the product side. So it is oxidized. So it is a reducing agent. But on the other side copper 2 plus from the reactant is going to 0 in the product. So it is getting reduced. So it is a oxidizing agent. Now redox half equations. So every redox reaction can be split into two half equations, one showing oxidation and one showing reduction. So first step is write oxidation half equation. So show the species that is losing balance atoms first, sorry, and then add electrons on the right side. Okay. And second, write reduction half equation. Follow the same thing. Balance atoms first, then add electrons on the left. Now, in the overall reaction, there should not be any electron. So you have to cancel the electron. So basically, multiply your oxidation and reduction half reaction by numbers so that their number of electron becomes equal. So in this case, you multiply the iron equation by 2 and 1 for the chromium. So they both have 6 electron each side. So the final step is add the half reactions together, and then you get 2 iron plus Cr2O7 di negative, 14 as positive, giving 2 iron 3 positive, 2 chromium 3 positive plus 7 water molecules. So here you can see there are no electrons, only the atoms and the ions. Now here are some practice problems on oxidation number. First one is what is the oxidation number of manganese in MnO4 negative? So apply rules 3 and 6. Oxygen is -2 and total charge is -1. So if you assume oxidation state for manganese is X, you can use the equation and can find the X value. So X plus 4 oxygen atoms, so 4 times -2 and overcharge is -1, so equal to -1. Here you can get solve for the equation and can get X value which is +7. So manganese oxidation state is +7. Similarly, you can solve other problems. You can pause the slide and you can solve problems on your own and check the answers. Practice problem on oxidation and reduction identifying. So they like question 5 in the reaction zinc plus 2HCl giving zinc chloride plus S2. Identify what is oxidized and what is reduced and name the oxidizing and reducing agent. So here you see on the reactant side zinc is in zero oxidation state, and in the right side in the product side zinc chloride zinc is in +2 state. So zinc is going from 0 to +2. So zinc is oxidizing. So it is a reducing agent. Now, similarly for HCl, HCl on the reactant side is +1 and it is going to 0. So it is accepting electron. So it is getting reduced. So it is getting reduced. So it's a oxidizing agent. So you can pause here also and can solve other problems. Here are a few more problems to try. So key takeaways, oxidation number. Oxidation number is a bookkeeping charge assigned to atoms to track electron transfer, not a real charge. Rules apply rules in order. Pure element 0, monoatomic ions is equal to charge. Oxygen is mainly -2. Hydrogen is +1 or -1. -1 when it is attached to metals. And oil method, oxidation is loss of electron. So increase in oxidation state. The species oxidized is called the reducing agent. Similarly, rig, reduction, gain of electron, decrease in oxidation number. The species reduced is the oxidizing agent. And write the equation, redox reaction split into two half equations, oxidation and reduction, balance atoms first, then balance the charge, and then multiply so that you can cancel the charges when you add two equations. Thank you.